Hello viewers and welcome back to my channel. Today's video is about my upgraded Vevor 3018 Pro CNC and my initial thoughts after having used it for a few weeks now. We'll go over the machine, all the upgrades and modifications I've done to it so far. We'll do a cost breakdown of everything and check out some carving results. So if that sounds like something you'd be interested in, then stick around and let's get started. I originally wanted to start using a CNC as something new to the things I make with hand tools and a 3D printer. And the first thing I did was a bunch of research. It was a bit overwhelming in the beginning since I had absolutely no experience in machining or CNC machines overall outside of my 3D printer. But after watching probably 1,000 YouTube videos and reading hundreds of forum posts, I came to the conclusion that I would start small and that I would build my first CNC machine by myself using a kit and some upgrade parts. My idea was that I would learn how things work and get a better understanding about what affects what and which aspects of the machine are important to the use cases that I'm interested in. And in the end, my goal was to have a larger and more robust CNC machine that I can use to machine even harder materials like steel. That will definitely not be this machine, but I might be machining some parts of it using this machine. So I decided to build my machine from the beginning with the control electronics separately, so I could have more options to cover and shield the machine and prevent chips and dust flying everywhere. I mounted the CNC control board as well as the spindle control box and a potentiometer on a piece of plywood, and I made longer cables for everything and I shielded them with a heavy-duty cable sock. After that, I thought of a bunch of options for an enclosure for the machine, but actually I ended up just using a plastic storage box, which I slightly modified to let the cables move freely. I did this because I'm not sure yet if I want to expand the cutting surface of this machine, and I didn't want to commit to a more elaborate enclosure yet if I would need to change it soon anyways. But the plastic box works great, the chips and dust stay inside, and it's still possible to see what's going on through the clear plastic. So with the background out of the way, what is it that I exactly have now and how much did it cost? I'll put the prices here on the screen, both in US dollars and in euros, which is what I used to buy them. Well, the machine itself was 184 euros. The upgraded spindle with its control electronics were 125 euros. The Z-axis upgrade package was 83, and the spoil board was 18. The set of the longer motor cables was 3 euros. All of these included shipping, and I ordered all of them from Aliexpress. In addition to those, I also 3D printed some parts, such as the cable guide, and I also 3D printed a bunch of other parts that I ended up not using for one reason or another. I'll talk about them in a minute, since they would be useful for someone not setting up the control electronics separately from the machine, and if you would use the original Z-axis. I've also included the linear rails in this calculation since I've already ordered them, and they are definitely needed for cutting metal on this machine. They were 70 euros. On top of these, I also used a bunch of screws, bolts, zip ties, plywood, and things like that I had laying around, as well as the plastic enclosure box for the machine. Let's call those 20 euros in total. In the end, the total so far comes down to about 500 euros or 540 US dollars. Of course, you would then add things like end mills and collets and material and so on, but so far I've only used the end mills that came with the machine, and all the material I've cut has been stuff I've had laying around anyway. So could you buy a better CNC machine ready-made with the same price? Almost certainly yes, at least from some perspectives. Manufacturers like SainSmart have the 3020 Pro Max V2, which has both the upgraded Z-axis, it has the linear rails on the X-axis, and also an upgraded 300-watt spindle. That is probably the closest machine to most of the things I've done here in a ready-made product. It costs about the same as well. But I wanted to learn while I go, and I hope many of the upgrades I've bought here are universal enough that they can fit into future projects too. For the other 3D printed parts that I didn't use, here's the breakdown. I printed a cover for the spindle control electronics, as well as a mount to attach it to the frame of the machine. I also printed a holder for the Z-probe, some braces to be installed between the 2020 aluminum extrusions on the X-axis to make it more sturdy, and a more elaborate cable guide set. I didn't end up using any of these except for the Z-probe holder, but if you would set up a similar machine and you wouldn't have the electronics separately and you wouldn't have the upgraded Z-axis, then I would recommend all of these parts. I'll link to them in printables if you're interested. So how does it work? Pretty well, I think. The spindle is nicely balanced. I think I had good luck with that, since I've seen a lot of YouTubers with a similar spindle upgrade struggle with vibrations, mostly due to unbalanced fans. Mine is spinning pretty nicely, even at top speed, without much vibrations. The machine is actually overall much more quiet than I'd anticipated from all the other videos I've watched. It might be reasonably used even in an apartment if you are just cutting soft materials like plastic or wood. The noise really isn't bad. I would also definitely get one of the models like I have here that include the manual jog knobs at the end of the axis screws. I've used them already dozens of times, and it definitely would be a hassle to have to do all of that through the control software every time. So what should then be improved here? Well, the lead screws, both in the X-axis and the Y-axis, would benefit from some anti-backlash nuts, which I've already bought, just not installed yet. Machining softer materials like wood, it seems like there's not much difference there, but I suspect that with any metal, the lead screw movement really needs to be more accurate. Another thing that I would add is an e-stop. I had one job almost break an end mill as the cut depth was set incorrectly on the toolpath, and the end mill drove directly down all the way through the material and the spoil board in one go in a fraction of a second. Luckily I was able to pull the power cord out of the socket and there was no damage, but a big easy to use button would have been great. I'm using an old Surface laptop as my method of control right now, and the software that I've used is UGS, Universal G-Code Sender. It seems to work fine, although I have had some issues dealing with the Z probe for some reason. Probably it's just me not doing it correctly, and I'll do some more testing in the near future with that. But for right now, I'm setting the Z-axis 0 using a sheet of paper, just like with a 3D printer. I've also printed out an extremely helpful cheat sheet of G-code commands to use directly with the UGS console. For some reason, all of the 3 axes on my machine were reversed in the beginning when I built it, at least with UGS. So everything moved back when it was supposed to move forward, and everything moved up when they were supposed to move down. I don't know what caused that. The cables can go into their sockets only one way, so they can't be installed reversely. But there was a simple command to invert them that I found in the cheat sheet, so that solved it all in one go. The design software I've tried so far are Fusion 360 and Easel. Easel is really simple and by far the easiest to get started with, but it also seems very limited. I use Onshape for my 3D modeling normally, so I'm not that confident with Fusion 360 yet, and the toolpaths especially still have a learning curve for me. But I'll keep practicing and I'm sure it'll be fine. So what's next? Well, I've ordered the linear rails that will be replacing the rods on the x-axis, and as soon as they arrive, I'll move on to machining aluminum. But that's it for today's video. Thanks a lot for watching and I hope to see you again next time.